look at some tree stuff, which I think are good to know. I'm going to talk about some ways to solve tree questions without even thinking, right? I want us to actually do that. Um, should I? Okay, let's see. Do we I should just look in the coding thing, or I should write down? Okay, let's look at this. Let's pick trees. Okay. I hope now everybody can solve in order, pre-order, post-order. Everybody can solve that, right?
Yeah.
Okay. And I hope people have
Yes.
learned, please, for the iterations, please learn the recursive approach and learn the iterative approach. Like, okay. Let me tell you the truth. I have been in an interview, right? Where they told me to do, was it? Oh, it was level order. Was it? It was one of the traversals, but they wanted me to do it in the iterative approach. Like, it can happen because you enter an interview, they give you the question and you finish solving it in 4 minutes. Recursive approach. It probably came with only one question. You'd be like, can we do it iteratively? Bro, just solve it, right? You get what I'm trying to say? Like, just take the extra step. It's not hard. Like, we can try to do it now. Actually, let's do it. It's been long I solved it. So let's try it together. Okay, can we all read the question to make it make sense? Does everyone understand the question? Everyone understands it?
Given the root of a binary tree, return the in order traversal. Yeah.
Can we go? Can we start? In order.
Yeah, you know that.
In order, right? I hope you understand what that does, right? I'm going to explain this solution as I remember as I learned it's like. When did I learn this thing? 4 years ago. God has got us. Okay. But we understand the question. Can we go? Ready to go? Hey, Obi and Fime. Let's use this one.
Yeah, ready.
Yeah.
My hint number one. Whenever you get a tree question, this is what I do. I'm showing you how we do tree questions, or at least how I do mine. So what I do is that I always try to write my solution for a 3-node tree. So I'll just say 1, 2, 3. That's how I solve my tree questions. I write an algorithm which I know is going to work for these 3 guys, right? I'm going to do the iterative approach. Recursive approach, everybody should be. We did it last week, right? Like, come on. So what I'm going to do is that I'm going to do an in-order approach, right? So for the in-order approach, usually what I'm going to use a deck for it, right? What I'm going to do is that I'm going to, in-order is what? Is a current first, right? Then left and then right. Actually, should we just do a regular tree level order traversal? Let's do a regular tree. I think that is a good foundation start from. So give me a second. Let's do a regular level order traversal for a tree. Pay attention. Let's just do that one first, right? Then we can just modify that one. So let's say we have 1, 2 here, 3. All right. I want to print the tree level by level, right? You just want to get the notes like level by level. Does the question make sense to everyone? Level order. Okay. So let's call it level order. So what I'm going to do is that, please follow me carefully. I've walked through the solution before and like there's a video on it and it's just, yeah. Okay, let's pay attention. So what I'm going to do, I'm going to follow my variables. Let's see what I'm going to do. I'm going to use 2 variables, namely current level. This is how I learned this thing at first. Follow me. And I'm going to use something also called a next level. Next level. Now, current level is a level being processed. Current level is a level next to be processed. Please, do these 2 things make sense to everyone? Current level, the level being processed, currently being processed, and this is level next to be processed. Does this make sense to everyone?
Yeah.
Comprenez-vous, tout le monde? Everybody understands, right? Can we continue?
Yeah.
Please follow me.
Yes.
Yeah.
Okay. Now let me ask you, what is so when I start the code, when I start my algorithm, right? Let's bring the root here. The current level or the next level I'm going to process, what's the next level I'm going to process if I start this algorithm? It just contains the roots, right? Do you agree? I'll come to start my code. So my next level to process is just containing the root node. That is 1. Make sense to everyone? Please follow me carefully. Okay. Now, while there's a next level to be processed, you see how I'm writing the code? Okay. Now there's a next level to be processed. Now come to process it, right? So I'm going to empty that one into current. All right. Now you're about to be processed, right? And now I'll empty this guy. So what is the next level to be processed? And now I'm coming to process you like you're in trouble, right? Like you're in the machine to be processed. And I track all those things with my current level. Does that make sense to everyone? So I just empty you into this guy. Does that make sense to everyone?
Yeah.
Then next level is like empty, right? Because now I'm coming to do the after work.
Why can't you not use dot append next level?
But like it is the same thing, right? I can just do like for node in next level. I can do like current level dot append.
Wow.
Yeah, I can just
So
do the
current level equals to next level semicolon. They're all the same thing.
same thing. Yeah, this just means make a copy. It's just copy the by work, right? You can do this or that. It's the same thing, right? Everybody understands?
Yeah.
Now I'm coming to do the processing. So what is the process? Let's say we are printing it out, right? So now look, let's process this guy. Let's process it. So for every node in for every node in current level, let's assume I want to print the node, right? So I want to print node.value. Can we all see it? So I'll print it, right? So at the start, it just contains node 1, right? So I just print 1, right? And now I'm now coming to populate my next level, right? So now I'll be like populate next level. So this is like process current node. This thing I'm showing you, you see how you can use it for almost everything. Process current node. So populate next level. So how do you want us to print the order? You want it to be from left to right, right? Like left, like 2, 3, right? Okay, so now do next level. So let's get the left node. I'm basically writing like redundant, but like it's fine. Node dot left, right node is going to node dot right. Let's exclude, we don't care about NaN, right? We don't care about NaN. So if left, next level, dot append left. If right, next level, dot append right. Does that make sense to everyone?
Yeah.
And beloved, this is the whole code. We are literally done. This is the whole code. We are done. That's the level of the traversal. I think we're done. Yeah, we're actually done.
Why
We're done.
printing instead
Oh,
of
I just want to show the value. Like I can accumulate it. Like I mean we can decide to accumulate, right? Then like put the nodes inside the list, right? Then this would have been like res.append node of val, right? But this is the whole solution. Does this make sense to everyone? This my algorithm for level up traversal.
Yes.
And we can actually do this for in-order traversal. We can do it for like you can just manipulate this guy and like everything else works. But I want you to understand this thing I just wrote here. For me, it's kind of my fundamental. You see, I did this in like 4 years or 3 years ago, and I'm still able to regurgitate it because I'm like current level, next level. That's literally how I learned this thing myself. Like if I'm coming to process you, I'm going to empty it into current level, and this solution up here solves a lot of problems. Let me show you one of those problems it solves. Sometimes, if you don't see this, you see how I'm resetting the next level thing here, right? If you don't take care, right, this is something people don't do. If you don't take care, as you're looping through, let's assume you're using just one variable, next level, right? You're like, oh, let me loop through next level here. Please follow me carefully and print it, and then maybe print it and everything. Consider you also appending to next level here. If you don't take care, you process the current elements together with that's for future levels. Can you see it? Because you are printing it or you are processing it and also appending its left and right to it. So if you don't take care, what you end up doing is that you process the parent together with the children. That's why I say it just makes sense. Like if you loop through the next level and also append to it. So it's dangerous to loop through something and be modifying it. It's actually dangerous. But if you don't take care, you modify the current node. So here, let's assume node contains just the root node 1, right? And then you're looping through it as, so then you only want to print 1. But as you're printing 1, also appending 2 and 3 is children to it, right? So when it comes, the for loop will be like, oh, there's still a node in it, right? And then it will, process those ones, which is wrong. Does that make sense to everyone?
Yes.
So the way to solve that is sometimes people get the length. Like I thought I'm writing C code. Like current level length, right? Or let's call it N. Is length of next level. This is also one way to also solve that problem. You don't use 2 variables. this is a way to solve. If you want to just use one variable as a length, this is one way to solve that. Length of next level. And then now you do for I in range. For I in range n, to make sure that you only process as many elements as were originally in the level. Does that make sense to everyone? This is also one way to go about the code. So you see now I just use next level, but I have made sure that I don't process the future elements because I already got the size of the level, so I only go through it that number of times. Does that make sense to everyone?
Yeah.
Hey, I hope it
Yes.
makes sense. Those two things I just did. So if you don't want to, so this is one way to just get the size and just look through it as many times. Because if you just do for node in this, you may end up processing the future elements. So here, if you do this, you're just going to use as one variable, and then you are done. So you see, I went from a very brief first approach to this approach. Does that make sense to everyone? Okay, are we good to go?
Which approaches would you recommend?
I'll say this one. This one is better. So just use one variable, right? Like one list, and like just get the length and it's this number of times, right? And also shows that you know what you're doing, right? It shows that you don't want to mix two elements with different levels, right?
Yeah.
But the first one establishes that. Aside from the first one to build my mental picture, right? Okay, are we good to go?
What are we returning?
Oh, you can just return results, right?
Oh, interesting.
Yeah. Okay. Now, I don't think I can finish our trial and continue the trial on next week. But let's look at the solution for that. Let's do for pre-order actually. Let's do for pre-order. I feel like the pre-order solution may be more intuitive for some people. But so let's look at it. So you all remember this. You all remember that. If you all remember for pre-order, you all remember pre-order, right? Like everyone remembers pre-order, right?
Yeah.
Yeah.
Then for pre-order, let's just use another. I feel like in order is fine. Let's just use another because I feel like in order is more common. You remember for in order, there was left, no, right. That's what we did, right? Go left hand. So look, we look at this thing. We went left hand. We always went left hand. Then after we were done, then we process the node. Then we go right hand. Do you remember that thing? I want you to have that picture in mind. Like, you know that. Like you go left hand, and then after you're done, then you come, then you go right hand. Is that thing in mind? What I just said. Okay. Now let me show you something. Please show me. Okay, that's what we come to do. I'm going to show you right now. So this is the approach we have now. So look, the solution is just a bit, but just remember what I just told you. You go left, when you are done and you have hit it, then now you process the node. Then you go right. Do you remember that thing I just said?
Yeah.
It's important. As I said, like we come to this call for a very short time, but I can only tell you what is relevant. So please listen. Okay. So this is what we are doing here for the in-order traversal, the iterative approach. And this is literally what your recursive call is doing, the recursive implementation. So we take the current node, right? Then we take this current node, we go to its left. Can you see what we are doing here? You take the node, append it, then you go to its left, append, go to its left. Like you just like go to the left. Just go to the left. So here, so when I start from this tree you see here, at the end, it's going to look the stack is going to look something like this. Somebody tell me what the stack will look like. What the stack look like? Anybody?
Like this particular example?
Yeah.
In 4, 2, 1.
No, it's
4,
actually
5, 6,
Yeah,
7.
1, 2, 4.
1, 2, 4, right?
Yeah.
Because that's why we're using a stack. Okay, if we're using a stack and we're processing, which one will we process first? Is it the 1, 2, or 4?
The 4.
4, right?
Yes.
So it makes sense that it is 1, 2, 4, right? So what you did is that you're like while node, right? That is the root node. It starts at the root node, right? Just go to the left side, like append it, go to its left, now append it down. So you look something like this, right? Now, 4 has no child, right? So that means that we can now take the 4 out and process the 4. Does that make sense to everyone? So let's pop out the 4. So we take the 4. Can we see what's happening here? So now we take the 4. Then we process the 4. Here, process means append it to the result, right? Then we do that. Then what do? We take that 4, and then we go to its right side. Do you remember that?
Mm-hmm.
So then we now move to the right of 4. Then we come again, the while loop continues. Now put that right node inside, right? And then that right node to go to its left. That is basically the algorithm that is happening. Does this make sense?
Yes, that's right. This
Yes.
iterative
This is
very
the iterative approach, right?
Something, right? When I'm explaining,
iterative.
look, when I'm explaining something to you, I want you to understand what I'm saying first before you try to understand the code. Code is something you yourself can go and sit in the night and try to crunch, right? But like that's high level or that general explanation I'm giving you. Try to understand that thing first, right? Because look, in a coding interview, sometimes you can't even write out the code. But if you can communicate the algorithm, which is what I usually tell you with my like you pass the interview. Does that make sense? So don't try to understand both of them at the same time. Like you will be confused. Understand the explanation first, that logic. Like that thing I put, be like what the Cornelius put in his mind, which helped him repeat this thing. And it's what I told you. Once you have that thing in mind, the more you write code, it'll be easy for you to to repeat the code. Does that make sense to everyone? But some of you try to understand everything at an instant. It doesn't always work that way, right? It's a step at a time. So you take the current node, add it, go to the left. After you have ended 1, 2, 4, take out the 4, process it. Right now, the 4 you have to go to its right, jump to its right. Now, from the right to you append it that right node and go to its left, and then like that, and it works. Does that make sense to everyone?
Yes.
And you realize that if you look at, so please learn the iterative approach. It's good to learn it. If you look at, so this is pre-level, this in order. What we just did was that if you look at post order, we can literally change this code. It's the same thing. Like, look, it's the same thing. The thing with pre-order is that, so you see that, look at something here. So for in order, we know go left, process node, go right. Can you see it here? We just tweak this code. It's just a teeny tiny little bit. And we have the in order one. That's why I'm like, the trees thing, like sit down on them, like munch them, like sit down on them. Like you realize, look at the thing. Look, you realize it's the same thing. Can you see now for pre-order? We just do the processing of the node first, right? Then we take its right. Then we take its left. There's a reason why we do this one. The reason why, can you see why I've brought the right thing first? Can somebody tell me why I'm adding the right to the stack first before the left? Can anybody tell me why? Can anybody tell me why?
Because when we are popping, we pop the left
Pop from the
before the
end.
right.
Can you see we pop from the end first because it's a stack. That means that when you're processing, you actually process the left node first. Look, you put the right node first into your stack, and then you put your left node. But in processing, a stack, you only pop from the end. Does that make sense?
Yeah.
Yes.
So
Deep,
please,
deep, deep.
algorithms, make them make sense to you, right? Like make them make sense to you, and you'll be there. You'll be there. Also, people are a bit tired. We've been here like 2 hours. I'm going to end here. God willing, by the took much more time than I thought it would. God willing, next week when we come, we're going to do full scale on trees. We're not sitting down with trees, so we're still going to go. I want people to like see trees linked list, priority keys, and like this. These priority data structures are like, because look, if you be honest with yourself, after our lists and our stacks and our keys, and like you just linked list trees. Like these are very fun. Like you have to master them. Like every one of the data structures, like sit down. Some of you are still not done with trees. It's okay. I won't judge you yet. This week, finish it. When you're done with, if you want to master trees, but it's something I really want to show you, which will make your tree algorithm so easy. But we are out of time. It's like when you see, if you look at my solutions, right? There's a way I write trees questions, trees approach. Okay, how about we do it in coding room? Mr. In the coding room.
Yes. When are we going to learn BFS, DFS?
Cornelius, I
No,
think
we
we
do
should
graph.
get for coding room.
When we do graph, we do BFS,
Is
DFS.
it like entry or is it
But
graph?
already you're doing BFS and DFS. That recursive approach, right? For that's what we call DFS.
Yeah.
That's what we call BFS. You've already started doing that, but I just don't want to put the names on it. But that's all you're doing. This is like I mean the level. The level that we first did. This guy is just this is what we call BFS. This is literally BFS we just did. In graph algorithms, that's it. If you want to traverse a graph BFS, this is the only thing you change. So see here, we are doing this. For a tree, we are going a binary tree. We know it's always going to be a left child and a right child, right? But for a graph, it may be more, right? If you remember when we first did trees, so for a graph, what will happen is that you just be like for child in node or children, right? Or node, we usually use neighbors, right? Like for neighbor, once you do this, you have written a full graph BFS algorithm to always work. Then like you'll be like if neighbor next level dot append. Yeah. Basically, and this is a full scale BFS. The only we explained, right? A binary tree is a graph with only at most 2 nodes, right? Left and right. So like, yeah, so it's the same thing. So yeah, so let's go over this week's task. So this week we're almost there. I think we're finishing our thing, like very solid DSA thing by July. Okay, so we'll visit these guys, right? Don't worry. We'll visit Persecution and Keeps gone next week with trees. Do those three things gone next week. We'll do more of it. But I expect you to have done your perfect job. So when I bring it, I wanted to clarify things, and make you also my plan is that we finish most of these things before end of July. And from then we'll only be solving questions. We'll hop on a call with just solving questions, like just solving and solving, right? Oh, it was here. LinkedIn, we've done this one. Oh yeah, that was linear, but then I said we just did this today. Done. Okay, so now this week I'm going to be very kind to everyone, right? Like so kind. I know I'm probably the kindest guy you've met in life. You're welcome. Okay, so we're going to do tries. I'll add the resources soon. The core word first, and then bits manipulation, and then I need people to start graphs. I'll put the relevant resources to start a graph. Graphs are like some of the easiest to come across. I need you to start it. Look, I'm not going to actually change of mind. Yeah, we will teach it next week.
Okay, I didn't it next week.
Yeah. Sorry, I'm thinking a bit. Give me a second. I'm debating between backtracking and graphs. Which one I should do first? I think do graphs. Start graphs. I'll call it graphs 1. We will do graphs 2 later. I'll call it graphs 1. Okay. That's an intro to graphs. I'll put the relevant results, so don't worry. So we're doing what this week? Tries. You must know tries. Tries implementation is just one code. Just master the tries code. Unless I would have actually got a tries question before. Yeah. So, like, base manipulation to say is the reason for base manipulation are simple. I just need you to when I say I just need you to master these things. Like this, I want you to learn base manipulation. Like, go here, base manipulation. It's just some couple of topics like we usually do, right? Also for that one, set it to NIT code 250, right? And then, like, when you open the question like this for base manipulation, there's not many, like, because these are things that are throughout computer science. It's not like a book to learn everything. Already, some of you know and bitwise and then bitwise also. Now, when you solve the question, I want you to go to solutions. Based on place, I want you to look at other people's solution. Please try, do your best. You see, like, there are different approaches people solve it. Like, I want to take some of the questions, there are other ways you can solve it, right? Learn this one. Like, hey, this guy called the wall rules operator. Hey, don't mind this guy. It's a very good thing in Python. It's called. This guy is very fancy. Look at them. Oh, it's Golang. I'm sorry. It's also in Python, though. Let me show you what I mean. Let me show off a bit. Give me a second. Tell me if this code will work or not. Is everybody looking? Is everybody looking?
Yeah.
Yeah.
Okay, let's show off a bit, okay? Okay. Okay. It's been so long I did this thing. Let's see. I love it when I say when I usually see news, sometimes on news, I really like it. So let's see if I can bring it up. Will this code work? Will this code work? Anybody? Will this code work?
Looks like it.
Yes.
No.
Was
Really?
I is out of bounds.
Okay, kind of.
Yes,
Yeah.
it will work.
Will it work though?
No,
I don't know.
because we don't know the value of I.
That
Maybe.
Okay, we don't know. Right. Yeah.
I is from where? It's from Ghana, Accra, Lagos, Nigeria, or Abeokuta. You never know, right?
It will work because we don't know the value of R. So.
It's not like you don't like I is like not declared. It's not initialized anywhere, right? Like Python be like, wait, I is a variable. I've never seen this I variable before, right? That gives you a problem. Does that make sense to everyone?
Yeah.
But you can see that I is not binding to anything, right? It's not binded I to anything, right? Like,
Yeah.
right? So
Yeah,
then,
I think plus I.
yeah, but then look, if I do this, today,
What are you doing? It's Pythonic. Colin don't do Pythonic stuff, bro.
actually, I think I can do this.
It's deeply with Python but
Let's do is I. I did this thing like 20 million years ago. Let's do this. Let's just use if. Let's just use if. Let's start from the foundations. Let's say n is equal to, let's say if n okay. Mod is what? This one, right? Okay, now let's say nums is okay. Will this work or not?
I have no idea.
Yeah, me too.
my goodness.
Me too.
Walrus operator.
Oh, what have I done here? Line 4. Today,
What's semicolon equals to? I don't get.
give me a second. Me self, it's wait. It's don't worry. We will figure this out. Trust me. It's just a way to bind to the variable from the start. Gentlemen, I've not written this code in production code before. I think yeah. Okay. I think I just left some syntax somewhere. Like, so basically you don't have to define the variable. It basically assigns it. It binds to it when it's there, right? Like, my brain is tired right now. I'm sorry. Wow, this is a very helpful article. Thank you. Useless article, I meant. Someone said, remember the always operator. So what is actually an assignment operator, right? Where you don't have to, you needn't have defined the variable earlier, right? Like it binds it for you in place. Look, this is not the code I write. I wrote some. So basically what it's trying to do is, let me explain to you. Let me go from here. So basically, so you can see that config.username is some variable, right? And then can you see that this username variable is not defined anywhere? Like, can you see this n is not defined anywhere, right? Like, can you see it? It's not defined anywhere. Like, look, if I gave you this code, would this code work? No, right? Because username is some variable that is out of school. You've never seen it anywhere, right? But I said bind config.username value to it, right? Oh, maybe it could be that maybe this Python version does not support it. What Python version is this? Let's open regular Python because I think the syntax I wrote was right.
Online Python as well.
Let's try some. My ZSH will not finish updating today. Yeah, let's try. Yeah, because it's quite. See, by the way, it's this one of those cool things that you go and show off. Hey, sorry, it's been a long day. That's all I can say. Okay, let's start Python here. And then let's paste that there again. See, it worked. See, it's not I'm good at this, That's what I meant to say. Look, so yeah, this guy does not support the Python version. This probably supports Python version. So can you see that? So you all know that if I just can you see n is not defined anywhere, right? You can all see it, right?
Yeah.
It's not defined anywhere. But what I'm doing right now is that I'm computing the length of nums, right? And then I'm assigning it to n. So yeah, I'm binding so I'm literally like declaring and initializing n here. Does it make sense to everyone?
Yeah.
Because that
the length of n is 2. N is 2.
Yeah. So here
Length
n
of
is
nums is 2.
the value of n inside this if statement is going to be length of nums.
So 2.
Yeah. Yeah, basically 2. Does that make sense to everyone?
So what happened to 1?
Huh?
What happened to 1?
What happened to 1?
Yeah, 1.
Like you don't need 1 here, right? Like the value of n will be the length of numbers, right?
Yeah.
Okay.
So like if this is it, right? And I did. So let's say nums. What's the length of nums? By the way, this is correct to do 3 dots. They will know the type of 3 dots. So right now we're doing what we call classical Python. What's the type of 3 dots? Can you see it? This one is writing 3.0. You're welcome.
Oh,
Yeah,
thank
right.
you.
Classical Python. Let me show you another skill. Okay. And we're doing classical Python. What's the next skill?
Damn.
Using semicolons.
How many programming languages do you know?
Me?
Yeah.
I know like Like two. But the one I usually care about is like English. I'm kidding. I know, like, I don't know, I have to count. But I'm not really an expert at any language.
Hey,
But you don't need to be right to get a job.
I want to ask you a question. Like, it's like I'm trying to understand. Like, in any type, they ask you the strongest language. Oh, you say it's Python. But they want you to write in Java. You not be like, I know
just,
Java, but I can't know it like off. I need to,
it's
use
fine. Just pick up
the
syntax.
net kind of
But you-
search what I want to use it.
Even the creators themselves, there are many things they don't even know. Like, yeah. So look,
Even
next classical skill,
engineering.
using semicolons in Python, it will work. Can you see it work? So if you've been writing Java or C or C++, you use semicolons, still please come to Python. We are here for you. You can still use semicolons and so work, right? Can you see my semicolons?
Yeah.
Your way. You're welcome.
Thank you, Pat.
We can put everything on one line. Like how some
Kotlin, you should know
it work.
Kotlin calling this.
Oh, you want to, but if you write a semicolons, it won't work. This is yeah. So the semicolon is just like, so you can write a very ugly Python code, put everything on one line. Like nums is equal to 1, 2, 3, comma, if nums is equal to the empty list, print empty. If you're doing exams, you don't want your classmate to copy you, write a code like this. Print empty. Then it can be like, what again should we do? Anything, right? Just anything. Like
Return 0.
the rest is, let's leave the rest for the future. 1, 2, 3, 4. I think I've retired. Okay, so welcome to classical Python. Okay, so this is what we're going to do on this week. Tries, base manipulation, and graphs. I'll send relevant resources for base manipulation. Your people, even you got a couple of them here, and I'll upload this. And right when you're done, please go back to your trees and linked lists and master those topics again. I'll try and hold coding rooms before our next meeting to show you the tree stuff, because there are some trees that I think you should know. It's going to make your life easier. And then, God willing, next week, we're going to do backtracking and more graph algorithms. And then the last week, we do greedy algorithms and dynamic programming. And then guess what? We are done. And then we are done. Okay, stop recording. Now, my last